Alright, this is our Precalc 12 class, lesson 1.8. Unit 1 is called Functions and Transformations. Lesson 8 is called Operations with Functions. In this lesson, we're going to talk about what does function notation with operations look like, and then how do we add, subtract, multiply, and divide functions. So in general, when we talk about adding or subtracting or multiplying or dividing functions, we can write them as such. So like f of x plus g of x, f of x minus g of x, f times g, or f divided by g. But we have a more succinct way to write each of those. For example, f of x plus g of x can be written at like this, and we pronounce this as f plus g of x. Or f minus g would be f minus g of x, and so on. We have f times g of x, f divided by g of x, or f over g of x. Some examples. If we take f of x and we say it's equal to 3x and g of x is equal to x squared, we would say that f plus g of x would be, well, f of x plus g of x, so 3x plus x squared. Or if we said f minus g of x, it would be 3x minus x squared. Or f times g would be 3x times x squared. Or f over g, which would be 3x divided by x squared. So we can compose functions in that way. Talking about domain, if I'm adding two functions together, or subtracting two functions, or multiplying two functions, the domain of that composed, or the domain of that new function, whatever operation we're doing, the domain is going to be the overlap of the domains of f and g, the two functions. So let's say only positive numbers are invited to, like I like to say, domain is what numbers are invited to the tea party. Let's pretend that only positive numbers are invited to f, that tea party, but then g of x, only even numbers are invited to that party. So when I add or subtract or multiply f and g, the only numbers in the domain are the positive and even numbers. Now when we divide fractions, like f divided by g of x, the same rule applies for the domain. It has to be the domains in common of f and g, but also the bottom function, in this case g, cannot be equal to 0, which is one of our original rules. You can't divide by 0. Alright, so some examples here. If I wanted to say, let's say f of x is this expression right here, and g of x is this function expression right here, I can add those two expressions together. F plus g of x would be f of x plus g of x, or x squared minus 13x plus 36, plus g, so x minus 9. And we can collect like terms to get a final expression fully simplified. Right there it is. Same thing with minus. F minus g of x would be the f of x function minus the g of x function. So similar to example A, except we are subtracting g of x. So we're subtracting x, and we're subtracting negative 9, or adding positive 9. And then when we do that, we get a simplified expression right here. All right, a couple more examples. If I multiply two functions, in this case we're multiplying all polynomials. So g of x is a trinomial, 3 terms. G of x is a binomial, 2 terms. Up to this point in this class, we've multiplied binomials by binomials. So I've showed you my box method. It's a 2 by 2 box. But now we're multiplying a trinomial by a binomial. So I'm still going to show you the box, but now our box is just bigger. It's going to be a 3 by 2 box. And so each of our terms in the f function will have a column, and each of our rows will have a term for the g function. If you're asking how come it did 3 wide and 2 tall, just because. If you did the f function on the side and made it 3 tall, and the g function on top and made it 2y, you get the same box. It would just be, rotated. When you add the terms together, you'll get the same answer. Doesn't make a difference. So anyways, when we multiply those together, we have an x to the power of 3 term. We'll collect our x squared terms. We'll collect our x terms. So 117 plus 36 is 153. And we'll write our last term at the end. So there's our final answer. Example D, we're dividing two functions. So I'm going to take f on top and g on bottom. Notice I can factor the top function, and when I do so, x minus 9 is a factor of the top function of f. So I can cancel out x minus 9 as a factor on top and bottom, leaving with a simplified expression of x minus 4. So those are our final two answers there. Note the setup is not very difficult. It's pretty straightforward for each of them. However, when we multiply or divide, there's extra skills that we learned in Pre-Calc 10 and maybe 11 as well that will be necessary to remember to complete these problems. Like usual, if you have any questions, hit me up. Don't spend too long at home working on your homework. If you get stuck, just stop working on it and come to class with questions, and I'd be happy to help you. Anyways, so this lesson we've identified the different operations we can do on functions and the different ways we can write those functions. We've also performed the operations on those functions and got a simplified expression. And hopefully we're starting to build our understanding of domain restrictions. And that's something we're going to continue doing. Domain is not going to be in today's homework, but it is coming. So, yeah. Tea parties.